OpenAI just dropped GPT 5.5, right? And literally, only a few hours later, boom, DeepSeek shows up with V4. Welcome to this explainer. Today, we're diving into what is honestly a massive disruption in the world of AI coding agents. Look, DeepSeek didn't just release another model. They rolled out a fundamentally different approach to cost, infrastructure, and long context reasoning. We're going to unpack exactly how a model packing a 1 million token context window and seriously strong coding chops is fundamentally flipping the economics of artificial intelligence completely on its head.
Here is our roadmap for the explainer today. 1. The DeepSeek V4 shockwave. 2. Decoding hybrid attention architecture. 3. Fixing multi-step agent amnesia. 4. Open weight versus closed ecosystems. 5. Benchmarks against frontier models. And finally, 6. Transforming daily developer workflows. Let's jump right in. Section 1. The DeepSeek V4 shockwave. DeepSeek dropped 2 versions of V4. We've got V4 Pro, which is a massive 1.6 trillion parameter model, and V4 Flash, a much faster 284 billion parameter version. Just look at the stark contrast in these numbers. This is pricing per million tokens. GPT-5.5 charges an absolutely exorbitant $30 for output. Claude Opus 4.7 sits around $25, but V4 Pro, just $3.48 for output. And V4 Flash, it drops to an astonishing 28 cents. Guys, it is a completely different universe of pricing.
To put that into perspective, that single data point means V4 Flash is over 99% cheaper than Claude Opus 4.7's output pricing. 99%. This isn't just a marginal discount or a promotional deal. It fundamentally rewrites what independent developers and small teams can actually afford to build. When a model doesn't need to beat every single closed-source system out there but is good enough, open enough, and literally costs pennies, it changes the whole game. Section 2. Decoding hybrid attention architecture. Okay, so you might be wondering, how on earth are they offering this without just bleeding money? Well, standard attention mechanisms scale terribly. If you double the context, your compute basically quadruples. DeepSeek's answer to this massive scaling problem is a hybrid system. On one side, you have compressed sparse attention, which compresses small groups of 4 tokens. Think of this as a magnifying glass. It focuses that sparse retrieval only on the highly relevant, fine-grained details. On the other side, heavily compressed attention lumps 128 tokens into a single entry. This acts like a wide-angle lens, giving the model a much cheaper, global overview of the entire context. By perfectly blending that magnifying glass with the wide-angle lens, they make 1 million token contexts actually practical. And this architecture directly translates into real-world efficiency. NVIDIA themselves noted a massive drop compared to the previous V3.2 baseline. Check this out. V4 Pro uses only 27% of the single token compute and drops the memory burden to just 10%. Flash pushes that even further, all the way down to a mere 7% memory usage. That massive plunge in memory and compute overhead, that is exactly why they can charge cents instead of dollars. Section 3. Fixing multi-step agent amnesia. For anyone out there building AI agents, context loss during complex tasks is a persistent, massive nightmare. We've all been there. Well, DeepSeek introduces a fix for this, and they call it interleaved thinking. Usually, when models go out to use external tools, search the web, or run a block of code, they have to rebuild their entire context upon returning. Interleaved thinking essentially acts as an invisible thread. It ties the whole thought process together, retaining the model's underlying reasoning state across all those external hops, so it doesn't just drop the ball halfway through a task. Imagine a standard 20-step agent workflow. Step 1, you make a tool call. Step 2, perform a web search. Step 3, generate and run some code. Without this feature, older models might literally drop the ball around step 15 just because they lost track of their initial reasoning. And as we know, one mistake halfway through ruins the entire output. V4 preserves that reasoning perfectly from step 1 right to the very end. It makes the model incredibly reliable for deep research and complex coding workflows. Section 4. Open weight versus closed ecosystems. Unlike relying entirely on rented APIs from huge closed ecosystems, V4 offers some incredible deployment flexibility. It was released under an MIT license, with open weights right there on Hugging Face. It's completely downloadable and modifiable. On the hardware side, NVIDIA has already published day 0 support for their Blackwell and Hopper systems, and simultaneously, it's fully verified to run on China's domestic Huawei Ascend platforms. This dual compatibility means developers worldwide can completely bypass vendor lock-in and optimize for the exact infrastructure they actually own. This represents a pretty major philosophical shift in the space. To quote the release, you are not only renting the model through an API, you can build around it, customize it, optimize it, and deploy it on your own infrastructure. For enterprise teams dealing with strict data privacy requirements, actually owning your compute layer easily beats endlessly paying a toll to a closed API provider. Section 5. Benchmarks against frontier models. Let's take an impartial look at the data here. DeepSeek honestly admits there is roughly a 3 to 6 month gap behind the absolute best frontier models when it comes to general reasoning. And the benchmarks reflect exactly where V4 shines and where it trails. On Apex, which is a really difficult STEM benchmark, V4 Pro hits 90.2%, edging out Claude Opus 4.6. But then you look at Emilio Pro and Humanity's Lost Exam, and Gemini 3.1 Pro still decisively holds the lead. So the real story isn't that V4 magically beats every model everywhere. It's that an open weight model is competing near the very top in STEM and code for a mere fraction of the price. Of course, we have to talk about current limitations. Right now, DeepSeek V4 is strictly focused on text and code, highly optimized for STEM reasoning. Contrast that with models from Google, OpenAI, or even Xiaomi, which feature a native multimodal focus supporting text, image, audio, and video directly out of the box. So if your use case needs native vision or audio processing today, those closed ecosystems absolutely maintain their edge. Section 6. Transforming daily developer workflows. So what does all this crazy architecture, rock-bottom pricing, and benchmarking actually mean today for software engineers? Well, DeepSeek surveyed 85 experienced developers internally, and the results are pretty telling. 52% consider V4 completely ready to become their default coding agent right now. Another 39% are leaning yes. When the people actually building these tools are eagerly making the switch, it definitely signals that the performance-to-cost ratio has hit a perfect sweet spot for daily coding tasks. Because Flash is so absurdly cheap and Pro is so capable, the daily workflow is fundamentally expanding. Small teams can now afford chat summarization at just 14 cents an input. They can deploy routing and lightweight agents constantly using Flash. And with a 1 million token context window that actually works efficiently, developers can drop their entire codebase into the prompt or process massive legal and financial documents, all without fearing a catastrophic API bill at the end of the month. Seriously, tasks that were strictly reserved for heavily funded enterprises last year are now running smoothly on a solo developer's laptop. Which leads us to a final provocative thought. When highly capable open weights cost under $4 per million output tokens for Pro and under 30 cents for Flash, how does the premium closed model question change completely? It really forces us to ask, what exactly are we paying a premium for moving forward? This launch is challenging the entire economic foundation of the AI industry, and it's going to be fascinating to watch how the Frontier Labs respond. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.